Fatiha, why do you look so stressed?
Hi, I think I have a problem with this chapter.
Oh, what chapter is it? Oh, it's chemical equilibrium.
Hello, Assalamualaikum and hi. Today, my groupmate and I will talk about chemical equilibrium. So, let's go.
So, what is a reversible reaction?
Reversible reaction is a two-way process when a reactant can change into a product and then the product can change back into the original state of the reactant. The formula of the reversible reaction is shown below.
Okay, so for the concept equilibrium is the state in reversible reaction where the forward reaction rate is equals to reverse reaction rate where the system is in dynamic equilibrium. Furthermore, the concentration of reactants and product remain constant, so do not change over time even though the reaction is still occurring. The example is shown below.
Let me move to the next part, a characteristic. Characteristic of a system in equilibrium divided by three important characteristics. The first one is the closed system. Closed system means no product and reactant can escape or can enter the system. Second one is the rates of the value for a reactant and product is the equal. The third characteristic is no observable. So, such as concentration of a reactant and a product and also a color are not changed over time once equilibrium is reached.
Oh, by the way, do you know that dinitrogen tetroxide is a colorless gas and nitrogen dioxide is dark brown gas?
I see. Why?
It is because a temperature effects. For example, for the low temperature, we can get a bright color because lot of N2O4. But if that is in high temperature, the color change to dark brown because lot of NO2.
Kc is stand for equilibrium constants. It means the equilibrium concentration of product divided by equilibrium concentration of reactant, and each concentration of product and reactant must be times with their coefficient. To reminder, coefficient is a number of each molecule in a chemical reaction. The next part is a range of equilibrium. The range of equilibrium is involve a magnitude of K. Magnitude of K is depend with a concentration of a reactant and product. So, if the concentration of reactant is more than a concentration of product, so the value of K will be a small because it's mostly reactant. So the K value or the K range is less than a 10 times -3. Furthermore, if the concentration of product is more than a concentration of reactant, the value of K is more larger. So it means the mostly of product. So the range of K is the more than 10 times 3. Well, if this happen, it means the range of K, which means the value of K is between the small and large.
Okay, so for the determining Kc unit, how to determine Kc unit? So we got the Kc formula. Kc equals to product divided by reactant. So at here we need to find the Kc unit. So this is product and this is reactant. So product 2SO3 divided by 2SO2 O2. Kc unit is for 2SO3 mole divided by mole 3 and mole and so we remove that, so we get m mole dm3 and we change the position. So that's all.
In this formula show, the capital letter of A and B is the reactants and the capital letter of C and D is the products, and the small letter of A, B, C, D is a stoichiometric coefficient. If you reverse the reaction, you must invert the value of K.
Next, I'll be talking about equilibrium constant in terms of pressure. So, for reaction involving gas, the equilibrium constant is often expressed in terms of the partial pressure of the gases rather than the concentration. The equilibrium constant is then given by the symbol Kp. So, the formula is as shown below here. So, in order to find the equilibrium constant in a term of pressure, we need to use this formula. So, as the equation have been given here, we need to find the Kp. So, this the pressure have been given in the question. So, we just insert it into this formula. So, we'll get 0.618 for this equation.
The first one is homogeneous equilibrium. It means the both of reactant and product is present in a single solution or in one chemical equation. By a definition, a homogeneous mixture.
Moving on, I'll be talking about heterogeneous equilibria. So, what is heterogeneous equilibria? It is a system in which where reactants and product are found in two or more phases. The phases may be any combination of solid, liquid, or gas phases and any solution. Remember, solid and pure liquid do not appear in equilibrium constant expression. That is why whenever we try to calculate the Kc and Kp, we do not include solid and liquid. This because the concentration is counted as constant. Thus, we did not include the solid and liquid.
For conversion of Kc and Kp, the formula is shown above. So for your information, delta N is total moles of gas on the product side minus total moles of gas on the reactant side. And for constant, R equals to 0.0821.
The reaction quotient or QC. QC works just like the equilibrium constant K, but the difference is K is used only when the reaction is already at equilibrium. However, QC is used at any moment even when the reaction is not at equilibrium yet. QC help us determine if a reaction needs to shift left or right to reach the equilibrium.
For comparison of Kc and QC is Q equal K is the system is already at equilibrium. Furthermore, it will not shift in either direction. So the second one, Q more than K. The system will shift to the left and some products will be converted to reactants. For Q less than K, the system will shift to the right and some reactants will be converted to products.
Okay, moving on, I would like to talk about Le Chatelier principle. So, what is it actually a Le Chatelier principle? It is when a system at equilibrium experiences a change. Well, the system will shift its equilibrium to try to compensate for the change. Thus, that's the definition of Le Chatelier principle.
Point that is important to us for now, the effect of the changing in concentration. For information, that only involve the gas and aqueous. Okay, let's move the first point. The first point is the decrease the concentration or remove some of the species. This means the system will exchange some of the species and move it by the direction that produce it. Second point is the system will shift to produce more of the species. The third point is the increase the concentration will and add some of the species. This means the system will use the excess of the species by moving it in the direction that use it. Last but not least, the system will shift and produce less of the species.
Okay, for changing the volume, pressure for gases only. So first, if the pressure increase, that means the volume decrease, and same like the pressure decrease, that means the volume increase. Second, the system will shift to the least number of gas molecules if the pressure increase.
Exothermic reaction. When temperature increases, the equilibrium shifts to the left towards the reactants. As a result, less product is formed and the equilibrium constant K decreases. For endothermic reactions, when the temperature increases, the equilibrium shifts to the right. Here, the volume of K increases.
Okay, last but not least, it's by using catalyst. A catalyst works by providing an alternative route with lower activation energy for forward and reverse reaction. So, the catalyst does not shift the position of an equilibrium system. Next, it also doesn't change the equilibrium constant. Lastly, catalysts only increase the rate of reaction, thus shorten the time taken for the reaction to reach equilibrium. Okay, so that's all from us. Thank you. Bye-bye.